weeks away from finishing. We're well on schedule, so I'm not worried about that. You're getting to that point where you should really think about organising some extra time, if it's at all possible, to get ready for your final. Because, I mean, some of the stuff was like 2 months ago, right? You might be a bit rusty on it. And the final exam is everything, right, from week 1 to week 10. So you want to make sure that you've had a chance to look over stuff and prepare. 30% of your grade is going to be on that. So you don't want to shortchange yourself by not putting in, a little bit extra work and doing well. So we are on chapter 8. I think, and I hope that a lot of you will agree when we're finished that this is a much easier chapter than some of the heavy duty solving equations that we've been going through, right? There's some really heavy duty trig algebra and so on. This is not, hopefully, in my opinion anyway, not anywhere near as bad. We're going to deal with polar coordinates first. Right. Here's our usual grid. There's a point P. We call this Cartesian coordinates, sometimes called XY coordinates. There's a point P, X comma Y. Now, if you were thinking what that meant, wouldn't that mean you go X units that way and you go Y units that way, right? And you can tell someone any point in two-dimensional space by just giving the coordinates, right? X coordinate, comma, Y coordinate. And you may have thought that that is the only way in which you can tell someone where in 2D space a point is, but there's actually a second system called polar that you may have met from somewhere else. But what you do in polar is you start at the origin and you draw a line to the point that you're interested in, and you give two numbers. You give a number r, which is the distance away from the origin, and the second number that you give is called theta, and that is the angle that you make with the x-axis rotating in the usual that way. So can you imagine that you could describe a point P by saying it was 5, 30 degrees. Right? That's what it would look like in polar, right? So the way you would draw it, if you wanted to actually plot it, is you'd get one of those nice little things called a protractor, right? And you'd measure an angle of 30 degrees and you draw a line. And then you get your ruler out and say 5 inches, dot, right? So it works perfectly. Some shapes, some curves work much better when you describe them in terms of polar coordinates rather than Cartesian, right? XY coordinates. Polar has a few idiosyncrasies. If it's degrees, or it could be radians, but isn't at the same point. Right. That's one. Any point in 2D space can be described as this, but it's not unique. So here is the point P. Here is the point P. And there is the point P. Now, every single one of them is the same guy. Now, see what that one looks like. Make an angle of 30 and go 5 units. Gotcha. What does that one do? Well, go all the way around the circle, then make an angle of 30. Right? Same point. Right? Not unique. What would that one look like? Well, if you do an angle of negative something, don't you go clockwise? So you go clockwise 330 and then 5 units along. So would you agree that there's technically, isn't there an infinite number of different ways of telling you that point in polar? Right, you're just 3 of them. In Cartesian, isn't there only one way of doing it, right? It's 3, 4. That's it, right? There isn't other ways in Cartesian, right? X, Y, there's only one way of doing it. Strange, but this is also positive. And you might say, what on earth does a negative R value, a negative distance from the origin, mean? The easiest way to do this is to just realize it means this guy. So let me show you as a little picture what the point with polar coordinates -5, 70 degrees would look like. It would be very accurate, but it doesn't need to be. I'm going to draw 5, 70 degrees, right? 1, 2, 3, 4. Right, that's 5, 70 degrees. -5, 70 degrees is this guy. Instead of going that way, you go 5 that way. The easiest connection is to realize that a negative R value is the same thing as a positive R value, and then just add a straight line worth, right? Add an extra 180 degrees. Does that make sense? So if you ever have to plot a negative R value, well, you just turn it into a positive R value and add 180, or pi if it's radians. So we now have a new coordinate system called the polar coordinate system. Well, one of the first things you would want to do here is, how do you take Cartesian coordinates and turn them into the equivalent polar? And how do you take polar coordinates and turn them into Cartesian, right? How do you convert, essentially, right? How do you go from miles to kilometers, kilometers to miles, that kind of idea. So I'll draw another picture and show you how that works. Here's my X, Y guy. That's Y. That's X. And there's a little right angle triangle. And there's R. And there's theta. Now I can prove this to you, but just trust me. If you do the right angle triangle with sides X, Y, and R, and you do theta, you can do SOHCAHTOA, right? Sine of theta is this, cosine theta is that. And if you rearrange those things, you will get the following connections. The X is R cos theta, that the Y coordinate is R sine theta. So this is how you're going to convert from polar to Cartesian. So if I tell you it's 5, 30 degrees, can't you just plug 5 times cosine 30 and 5 times sine 30, and that will do it? Now, I would like to be able to do the other version, right? Which is how to convert from XY to R theta. Right? So here it is. R is the square root of X squared plus Y squared. Now let's just look at where does that formula come. See, if you look at this right angle triangle and you did Pythagoras, wouldn't R squared be X squared plus Y squared? So can you see R would be the square root of that? Do you see where that formula is coming from? Now this one's a little bit trickier. If you look at this angle, let's do it in a separate piece of paper. If you take the tangent of theta, isn't it the opposite over the adjacent? So how would you get theta? How would you get theta here?
the inverse tangent of y over x?
Now, the only thing you have to be careful about this formula is that there could be, and probably will be, two answers to any combination of x and y. And what you need to do then is you need to know which quadrant your guy is in. So if I say it's 5,1, it's the first quadrant. If I said it was 5,-1, it would be in the fourth quadrant. And the reason you need to do that is if there's two angles, one is 30 and one is 210, don't you need to know which one of those two is the right one, right? And so when you do the angle, you have to know what quadrant you're talking about to make sure you get the correct angle, because there's two. There's the angle the calculator gives you, or whatever the unit circle gives you, and there's the second answer that you can also get. Any questions so far?
I have a question.
Yes.
So on the first page, you wrote P is negative 5,70. How is that exactly equal to 5,250?
Well, if you take 5,70, that's this one. Negative 5,70 is this one. Essentially, it's this line, but instead of going in the nice direction, right, outwards, you go backwards. So that's where negative 5,70 is. That's the same as 5,70 plus another 180, which is 5,250. Now, if you want to do that entire angle, won't you go 70 plus another 180? You know, straight line is 180, and that gets you the missing answer. So what I'm saying is a negative R value is the same, excuse me, as a positive R value with 180 added on. So if you are, excuse me, if you add on 180, you'll get the guy. I'm not sure if that's a very convincing argument, but that's how it works. Any other questions? Okay. Then a lot of the questions we're going to deal with are going to be conversion ones, at least at the start. So this is question 2. They tell you the point P. It happens to have coordinates 1, 1, so I'm not drawing it any degree of accuracy. And they ask you to give its rectangular coordinates. Well, that's obviously 1, 1. And then they ask you to find its polar. Well, I know that x equals 1. I know that y equals 1. So r is going to be the square root of 1 squared plus 1 squared, which is the square root of 2. And I know that theta is going to be the inverse tan of y over x. It's going to basically be the inverse tan of 1. And I should have my unit circle around here. There we go. Now, when you want to find an angle that has a tangent of 1, there are actually two possible answers. And do they want them? They want them in radians. So in radians, isn't that one of the places? If you cover up the bottom, can you see y over x gets you 1? So one of the answers, one of the possible candidates is that one. And the other one, I believe, is way down here. And that's 5/4 pi. So how do I know which, because only one of these is the right one, which one to use? Well, it's pretty obvious. Would you agree this point is in the first quadrant? And if it's in the first quadrant, then there's my theta. So if you want to find what the point 1, 1 is, that's Cartesian version, in polar, it's the square root of 2 pi over 4. So you always give exact values, right? You don't call it 1.414. Are we good?
Would you use at all the plus 2 pi k for these for the infinite?
No.
Okay.
So technically you should, but you won't, because we have a kind of, I think it's common sense. If there's an infinite number of answers, don't you just want the answer in 0 to 2 pi? So there's an unspoken convention that you only give one answer and call it good, and always try and give the answer in the 0 to 2 pi range. Is how we get around that. The next couple of questions I didn't plan for, so I'm going to have to show you. If you give me a few seconds to clear out the answers. And here goes. After this, we'll go back to doing conversions. What you see here is probably not the most useful picture in the world. I would much prefer them to put the y-axis in, but I'm not in charge of this. And why you tell me the answer? I made you go away. I hate this default. You didn't see that answer, by the way, right? Okay. You want to find which one of these 4 points, P, Q, R, or S, corresponds to this guy. Now, the 4 isn't really going to do you any good because they're all 4, right? Every one of these is 4. But what is going to be helpful is to look at the angle. Now, if you go -3/4, doesn't that mean you go this way? Right? Not anti-clockwise, but clockwise. So which one of these two would be the equivalent of 3/4 pi? Because it really could only be that one or that one. Which is it then? P, Q, R, or S? And I'm saying it has to be R or S.
R, would be R.
Yeah, it's going to be R. Try that again. What? Now this one is connected to that one. Remember we had the guy R, which is this fella. This fella here is the same numbers, except there's a -4. So if this one here, right, R, is that guy, if you stick a -4 in front of it, don't you just go another 180 and it gets you to P? Does that make sense? This one R is 4, -3/4. So this one is 4, right, plus whatever it is to get you to there. And that is the end of those two little guys. So we're back to conversions. There's the coordinates, 3, 3, and we are going to figure out how to turn that into polar. The X and the Y values are both the same again, so it's a bit mundane, but we got 9 plus 9, which is the square root of 18, and we use style points, so you should call that 3√2. So R is the distance from the origin, which you can get by that. And this guy, if you plot him, is over here, so he's in the first quadrant. And theta is going to be the inverse tan of y over x, which is the inverse tan of 1. And we actually got the same guy before. That's pi upon 4.
Does it matter if you do it in degrees or radians?
They want the answer to be in radians. You know how they seem to like radians a lot more than degrees. So we're just going to stick to radians all the time, unless there's some, there's some indication that they want it as degrees. I suspect, but I haven't checked it, that it might take both. If you've got time, try one. And if you say, nope, it never took it, then the answer is it has to be radians, right? But there's no indication in the question that it has to be radians. It just happens to be that's what the answers are. So I'll try to get my paper wrapped up. Let's do the other conversion. Let's do that guy. I want to turn him into Cartesian. A little bit easier because you basically have a formula that you use and you plug and chug. And you don't even need to change anything like know what quadrant it's in or whatever. You just simply do r, which is 4, and the cosine of the angle, and 4 times the sine of the angle. Go to your unit circle. If you do the pi upon 3, which is this one, the cosine is a half. So 4 times a half gets me 2. And this guy is root 3 upon 2, which gets me 2 root 3. Would you agree that's a lot easier than Friday? Here's a coordinate in one of the two versions. And then, you know, show you one that's a little bit weirder looking, but it's actually it's not really any different. Is that guy? So we're going to turn it into its XY version. So the X is R cos theta, and the Y is going to be R sin theta. And it's going to be 3 root 2, the cosine of negative pi upon 4, and 3 root 2, the sine of negative pi upon 4. Now, what makes this just slightly awkward is that our unit circle only has values from 0 to 2 pi. And so we have to do a little bit of kind of backwards engineering. Negative pi upon 4, where is that on a unit circle? What positive angle is negative pi upon 4 the same
7
place
pi
as?
over 4.
Agreed? That one. And if you want to get the cosine, it's the x coordinate. So it's that guy over that, which I believe is 3/2. No, it's not, it's just 3, because the 2's cancel. So it's just 3. And this one is going to be negative root 2 upon 2, which I get is negative 3. So the answer would be 3 comma negative 3. Well, that was a lot nicer than I thought it was going to end. Any questions about these conversions? Do these basically, these ones are just plug and chug, and the other ones, you have a formula. The only thing you need to watch out for is what quadrant the angle is, in case they sneak one up on you. So let's see if I can sneak one up on you with this one. In polar, it's 2 comma 2 pi, right? So there's my r, there's my theta. And I want to turn it into x's and y's. The formula never changes. X is r cos theta, and y is r sin theta. And that's going to be 2 times the cosine of 2 pi, and 2 times the sine of 2 pi. Okay, 2 pi is here, cosine is 0, 2 times 0 gets you 0, 2 times 1, I got that the wrong way around, didn't I? 2 times 1 gets you 2, 2 times 0 gets you 0. Let's see if I can pick some better than that. Here's just one I'm making up myself. I'm just trying to be as awkward as I can think of. Now that's going to be 10 times the cosine is 17 upon 2 pi. It's been a while, probably week 1, maybe week 2. 17 halves isn't on my unit circle. How do you deal with angles that are too big? How do I get?
2 pi.
Right, keep taking 2 pi. Don't need to take any more? Any ideas how many you can get away with here? In other words, what do you eventually get here? 17 halves right now. If you keep taking away 2 pi's and then take it away and then take it away, eventually you'll get an answer that is positive and it's in the range 0 to 2 pi.
Take away 8.
Say it again, I didn't catch it.
Take away 8.
Take away 8. You're left with half pi. And so I'll find a half pi, which is up here. So that's 10 times 0 gets me 0. And then the y coordinate ends up being 10 times the sine of a half pi, which is 10 times 1, which is 10, yes. And that guy there in polar format is 0, 10. Sorry, Cartesian is 0, 10. Do you have any problems with those conversions? Do you feel comfortable if polar into Cartesian, Cartesian into polar? Okay, let's go backwards again. Let's try some in the other direction. Which one? Question 14. In Cartesian, I have 2 root 3 negative 2, and that's my x, and that's my y coordinate. And if I plotted the point 2 root 3 negative 2, it would be basically down here, right? It's in the 4th quadrant. That's going to be important in a few moments. Now, to do a conversion into polar, I need to find the r value, which is always pretty straightforward, right? X squared plus y squared. Negative 2 squared gets me positive 4. 2 root 3 times 2 root 3 gets me 4 times 3 gets me 12. And you put those together and you get 16, and it's 4. So I got half my answer. The missing angle theta is going to be the inverse tan of y over x. It's going to be the inverse tan of negative 2 over 2 root 3, which is going to cancel out the 2's, still negative, so it's going to be negative 1 over root 3. And I'm going to leave it. There's our duck. I'm going to leave it like that, and now I'm going to go and find where this guy is. So we need to do a y over x that gives you negative. So it won't be in that quadrant. In fact, don't I know where I need to look? Don't I need to look in the 4th quadrant? So I'm only going to look at here, even although there might be some answers somewhere else, only the 4th quadrant matters because that's where my point happens to be, right? If you cover those two guys up, isn't the y over the x negative 1 over root 3? Can you see it? Negative 1 y over root 3x. And that's 11/6. And that's how I figured out it was 11/6 pi. Now, if you want to know where the same thing could happen again, there is an answer that's a possible answer, but not in this case, over here. And let's see if we get it right there. Wouldn't that also give you -1 over √3? But that's a second quadrant answer. And we can tell by Cartesian which quadrant you're in, right? I can plot that and say, yeah, you're definitely in the fourth, right? You're not up there in the second. You're definitely in the fourth. And that's one of the most common mistakes people do, is that they get the angle wrong because they choose one in the wrong quadrant. Are we good? Any questions? Right, here's a baby one to try it. Well, maybe not a baby one, but here's a quick one. Last one of this questions. Version question 16. There's your X, there's your Y. If you know what you're doing, you can do it in a minute. So starting from, you got 1 minute. Find a polar for that. Okay, let's go for it. The R value is given by the distance from the origin, which is this formula. So -√2 squared plus -√6 squared. And that gets me 2, and that gets me 6. And so I get the square root of 8, which is 2√2. So that's half the answer done. Now, if I do a very, very primitive sketch, this guy is over here, isn't he, in the third quadrant? Right? Third quadrant. So when we go looking for the angle, which you can get by taking the inverse tan of y over x, which is going to be the inverse tan of -√6 over -√2. That doesn't look anything like these guys, but that's because I haven't simplified it yet. Won't the two negatives make it a positive answer? And won't a square root of 6 over a square root of 2 become a square root of 3? And I'm only putting it over 1 to make it easier to recognize it. Right? So √3, which I'm going to call positive √3 over 1. So I am looking for a guy only in the fourth quadrant. And top guy divided by the bottom guy should be √3. And that's exactly the one that works. So hopefully you chose 4/3 pi. So we now have two coordinate systems which are totally convertible, right? I can give you polar and you can tell me in Cartesian. I can give you an XY Cartesian. You can tell me what the thing looks like in polar. So the next kind of conversion is, what do equations of lines and curves look like when you do them Cartesian And how can you convert them into what would be polar? So let's start with this one. X squared plus y squared equals 100. Now, if you wanted to sketch that, wouldn't it basically be a circle radius 10? Are you all comfortable that you recognize the equation of a circle? Right? But what would that look like in polar? Well, what you've got to do is to turn everything into r's and theta's. Who cares? I got it. X gets replaced by r cos theta, and you square it. Y gets placed by r sine theta, and then you square it, and the whole thing's equal to 100. So that's what the equation looks like when you change it from x's and y's into polar r and theta. But we don't leave it like that. You know, we do style points, right? We want to make it as simple as possible. And the rules for this are pretty much the same rules that you always have, right? Make it look like the original, simplify it, and so on. And one added, well, I guess two now I'm thinking about it. You try if it's possible, because it won't always be possible, but you try and make it r equals stuff with the in it, right? And the second one is try and avoid fractions if at all possible, right? So if you square this guy, you get r squared cos squared theta. And if you square this fella, you get r squared sine squared theta. Okay, that was pretty straightforward. Anybody want to tell me what I could pull out as a common factor? Because we're working on the factor the heck out of it right now.
Take r squared out, and then cosine squared plus sine squared is 1.
And since that is 1, don't you just get r squared? It's 100. So far, so good. Now, one of the rules I mentioned at the start of this question is, if it's at all possible, write it as an r equals. So what could this be? R squared is 100. What would r be equal to?
Plus or minus 10.
Correct. Yet we only pick the positive one. Does the negative one work? Sure it does, but would you agree positive one just looks nicer? Now, if you think about it, aren't all the points on this circle all the points whose radius, distance from the origin, is 10? Does that make sense? R equals 10 makes circles. Now, what about this one, which is an example equation 17? Well, you start off the same way with every one of these questions, and that's turn all the x's and y's into r's and thetas. And then style points. And this is going to be really weird. As long as you do it to both sides, it's okay rule applies here. Anything you could do to both sides here that might make it nicer.
Divide by 2. 2r.
Oh, 2r, I like 2r better. Told you this is weird. Now the next one, I think we did an equation, solving an equation question that ended up looking like this. Pretty sure we did. What will I do to both sides to fix this guy? What shall I do to both sides?
Divide by cosine.
You remember doing that? And you're going to say, okay. And that looks really nice. I mean, there's not a lot there, but I can do better.
Subtract 1.
Nope, not this time.
Theta equals pi over 4.
Yeah, take the inverse tan of both sides and get pi of 1.
Couldn't you also just do divide by 2 on both sides from the beginning and then divide the x over, and then it would be 1 equals y over x, which is the same thing as tangent?
Yeah, that would work. Now let's try and imagine what that is telling me. All the points whose angle is pi upon 4. Well, if you do all the points whose angle is pi upon 4, would you agree you get a straight line? In fact, if you just continue it, you get the straight line y equals x. Let's do one more of these converting to polar. If I can find one. Yeah, how about this one? Oh, quadratic, right? I wonder what that looks like in polar. Well, r cos, almost got it wrong there. R sine theta, 9, r cos theta squared. Now, our goal is, if we can, to get it to be r equals. And if we can't, then we'll do what we can with what we have. So I've replaced the y with r sine theta. And I've replaced the x with r cos theta. So I now have 9 r squared cos squared theta. Okay, we need to do stuff. We need to make this prettier. And if at all possible, I'd like it to be r equals, which in this question can be done. It is possible. Tell me something to do to both sides that might make this prettier. Any suggestions? Going to tell you in a second.
You could divide r by both sides and then there'd just be 1 r. And then you could also
Okay.
make the cosine squared into, would it be 1 minus sine squared?
Well, you don't need to do that. You could, but I
Okay.
wouldn't bother about that. But that's good. That's a good start. Now, remember, the goal is to get r equals. So now that you've divided both sides by r, which we're assuming is allowed because r is not equal 0. If r is equal to 0, doesn't the thing just end up being a point in the origin, which means there's not a curve there? So that's why I'm getting away with that. Technically, you shouldn't divide by 0. But in this case, r can't be 0. Right. What should I do to both sides to get r on its own?
Divide by 9 cosine squared.
Right. And as nice as that answer is, it's not quite the prettiest it can be, because we do not like fractions in polar. So I'm going to try and figure out a better way to write this so it's not a fraction. So I'm going to take that 9 and just call it a 9th. I'm going to take that sine theta and I'm going to separate out the bottom as a cosine theta with another cosine theta. If you put that all back together again, don't you get the guy we had? There's the 9, there's a cosine, there's the second cosine, there's the sine on the top. Now to finish this off, what is another version of sine theta over cosine theta? What does sine theta over cosine theta get you?
Tangent.
And what is another version that doesn't have fractions in it of 1 over cosine?
Secant.
We are finished. We have made it r equals, and there's no fractions.